The purpose of this video is to try to summarize the many ideas that I've presented in the preceding 14 videos. It's a rather difficult job because what I'm trying to do is to present a different worldview that centers around the language of the triangular neighborhood networks and how I've been able to explore different aspects of topology and construction, organization, behavior. So let me proceed with the slides. Rapid prototyping is a very powerful technique. The comfortably plastic elements that come from Germany can be used as a rapid prototyping tool to explore many topological and behavioral ideas. These elements are particularly good at finding symmetries and topological patterns, and I've used them now for more than 50 years. The importance of the triangular neighborhood networks is that they provide a single constructive language that can provide, hopefully, an explanation from the Big Bang all the way down to quarks. This is my belief, and I think the videos in some way show this is true. The triangular neighborhood networks are recursive. What this means is that the same syntax works at all levels of structure and behavior. In the video on the Big Bang, I showed how different levels of structure might be applicable to various features in the universe, such as the formation of galaxies, the formation of stars, the formation of atoms, etc. The recursive nature of the triangular neighborhood networks argues that the number of toroidal holes at all levels must be conserved. This in itself leads to many of the conservation properties. The ability of toroidal holes to move up and down levels of recursive triangular neighborhood network structure makes it possible for the universe to expand and to evolve new properties. The scaling of triangular neighborhood networks as a graphical construction technique is justified. But in naturally evolving triangular neighborhood network systems, scaling increases the number of toroidal holes, and this is strictly forbidden. Perhaps the Fibonacci chains may play a role in the solution to this particular problem. This slide discusses problems that I don't know how to solve. The first is, how many nodes should there be in the next level of structure for an edge? I don't have any idea of how to solve that problem. The second thing is, how, using triangular neighborhood networks, do you build all the particles in physics? I don't have the experience to be able to do that. In the video on the Big Bang, I discussed the question of how properties of the universe could be assigned to the various levels of recursion of the triangular neighborhood networks. What we tentatively said was that the first level is primitive growth. The second level is the motion of the arms of the universe. The third is the formation of galaxies. The fourth is star formation. The fifth is atom formation. Sixth is nuclear formation, and possibly seventh is particle formation. These are very tentative assignments, and maybe as time goes on, we'll be able to get a better sense of whether these are the relevant assignments, or whether there are other intermediate levels of recursion, or whether there are fewer levels of recursion than we have here. So this slide discusses what I think I'll do in the future. First of all, I'll try to build more structures in the computer, and this is a very difficult task, and but I'll try to work on that. Then, of course, I'd like to do many more simulations, and I'd like to do much bigger simulations. Computers certainly allow that these days. But the main thing to do is to try to get the toroidal hole to move. Once I've managed to get a toroidal hole to move, then this solves the problem for all the levels of recursion in the triangular neighborhood networks. The Knupfli plastic elements can be purchased from Dusima. This is the page that you want to copy and look at in detail. You can get their catalog from their website, dusima.com, and the Knupfli products are on and after page 150. The Knupfli elements are about 25 euro per thousand, and you have to get a quote from Maria Zambito, and then you have to send them exactly the amount of money by wire transfer. I want to thank you for persevering with me in these videos. I know it's been a very long process. Once again, I hope the ideas come across, and if there are glaring deficiencies, please tell me about them. I've included at the end of each video my full name and my email address. You can send comments, suggestions, ideas to me, and I'll try to respond to them. I would hope to be able to post new videos as I do additional work and find solutions to the problems that I've outlined. If you choose to, please subscribe to the Topological Dynamics channel, and as I make new posts, you can be alerted to their existence. I hope you enjoy yourself, have enjoyed yourself looking at these videos. As I said, certainly I've enjoyed making them, and I've learned a lot. I mean, there were many problems that I had ideas that I've worked out in my notebooks and I've worked out in the Knupfli models. But in forcing myself to bring all of these ideas to a video form, I've actually solved a lot of problems. And I don't know, I'd like to say I believe that the triangular neighborhood networks are the way the universe is constructed. But that's just a belief on my part. I would hope to convince you that this is true. This is a sample of a triangular neighborhood network in the Knupfli representation.